Hey guys, welcome back to the shop. I'm jumping back on to the machining for the dynamic jaw for the Hardtail Vise, and I wanted to go ahead and show you how I'm setting this up, because I began my initial setup so that I would make sure that what I wanted to do was going to work. I have a couple of different options on how I can set this up to use the Kearney Tracker horizontal mill to do this, and I've already run into a roadblock, so I've got to kind of change my setup here. One of the things that you have to keep in mind as a machinist as you're setting parts up, if you've got more than one op, obviously is the second setup, the third setup, or multiple ops that you got to do. And I wanted to be able to set this up and be able to do two different operations with one setup. And I've run into a roadblock, so I'm going to pull you in here, show you what I've already started with, and how we're going to change this so that we can hopefully complete all the machining on this the way I wanted to do in the Kearney Tracker mill. So this was my first idea, is using a big 8-inch vise there to hold this and be able to come in here and use a big face mill to mill this right there. And we could also come in here and do our milling here or there as well. And the face mill was going to work out pretty good, except for one thing. The big face mill that I have will not get up underneath here, at least to this point. It's just too big and bulky to get all the way up underneath here. So that's going to pose a problem, but I have a solution in mind on how to do that I think will work really well. But the biggest problem is this area right here that we have to machine for the jaw that bolts on there. This will not go down far enough on the mill to be able to put cutters in here and be able to cut that. All right, you see where they're at right now? I have the knee lowered all the way down as far as it'll go. So that is just elevated too high to be able to get in there and mill that. And I really wanted to get this milled and try to mill this at the same time without having to break down the setup. So this is one of the limitations to some of these older manual milling machines like this, is that you just don't have as much travel as some other machines do. So this is kind of stuff that you run into when you're trying to set things up. But it was looking really good. The vise, I mean, for milling this right here is going to work just fine. We've got the big 8-inch vise. I've got a planer gauge out here to support this in. We were going to use a toe clamp there. And then I had a machinist jack over here, or a planer jack on this side, that you could run up there to this area here. And then the same thing, put a toe clamp right there just to support the outer end. It really doesn't need much, but we just want to make sure that we were going to eliminate any kind of ringing that you might get from this unsupported area. But anyway, we're going to break all that down. I think I'm going to just take the vise off the mill, and we'll see about laying this or setting it directly onto the mill table, since we have a good machine surface on the bottom, and maybe just use toe clamps on the end. Maybe we can put an angle plate on there to help support it. I'm not sure yet, but I'm going to go ahead and start working on that setup, and I'll show you how we end up getting this fixtured so that we can do our machining. The other option is to lay it over on its side. That's kind of how I was originally going to do it, was lay it over on its side with it overhanging the mill table over here, and then doing away with the vertical head, take this off and just use the straight horizontal spindle to come in here and do the milling. That might be another option that we consider by doing this. But this is what it's all about right here. Having fun with our machines, our tools, and using them however we need to get the job done. I'm enjoying this project. I'm just trying to figure out the best setup that we can do for this dynamic jaw. The Skyhook always proves to be a nice handy tool around here. As I mentioned before, this is excellent to help you pick up heavy, bulky things like this, such as workpieces or these big vices. You're not having to kill your back, and it's easy to just mount it right to your machine. I got a tool post that I mounted in, and I had to make a riser block so I could just get a little bit of extra reach out of it here, extra lift capacity. So what I'm going to do for now is just got this loose here. I'm just going to slide the vise down for now, get it out of the way, and I'll reposition the Skyhook so I can pick up the vise and get it off. And we'll just set it right back down here on the table. I need to get this cleaned first, and we'll set it down. Just getting the oil up, use our precision stones. Make sure that it's good and flat. Just removing any burrs that might have encountered during the last use. All right, that's looking good there. Set it on these guys for now. And you can easily pick up one end and get things out of the way. Got the vise hook mounted on there. I just got a couple of 5/8 bolts. I replaced the cap heads and just put them on the back to keep them in place. And you just balance it by moving that jaw wherever you need to get the vise balanced. About as high as that'll go. Makes that task so much easier. All right. Okay, I think we're on to a pretty decent setup right here. Let me show you what we've got going on. We've got our toe clamp on each end. And then I've got these ground spacers on each corner of the entire vise body. So it's actually setting on 4 points. And right here, and then one on the other side. I did notice that there is a very slight amount of crown to the bottom surface that we shaped. And without some inspection, I'm not sure if that's just because of the shaper or the mill table. But when you set it down on here, you can tell that it's trying to pivot in the middle just slightly. So I thought it'd be best just, instead of trying to bend that 1 or 2 thou, whatever it is, let's just set it up on these spacers. Plus, it's putting the pressure point further away than just in the center there. All right, so it's clamping down on the outside of the casting. And I think that'll work. We've got an indicator set up. I need to get it trammed in nice and straight. And we'll do that next. And then we'll take a measurement to see what we need to take off here. It's not gonna be very much. It's gonna be about 1/8 of an inch is what we gotta take off of that. Let's go ahead and see how far out we are. I just eyeballed it, so this will be the first time checking it. That is not too bad. Oh, camera's in the way. And the wrench. Okay, 40 thousandths. Not too bad. Oh, may have landed on it right there. Oh yeah, that looks pretty good. Less than 1/2 thousandths across whatever that is. I don't even know. Let's check it and see. Just over 20 inches of travel there. Pretty good. Go ahead and snug up our toe clamps. I think I decided we're gonna go with our 4-inch Walther face mill, and the reason why I'm gonna use this one, I've got 3 of these large face mills. They're all about 6 inches in diameter, cut diameter anyway. But there's no benefit of using one of these larger ones versus the 4-inch Walter, because none of them are going to go up in there and cut all that. They're all going to come right up to this part of the casting, and you have to stop. So there's really no reason to use one of these. Now this is a very older style of face mill right there. It uses a big CNMG insert. It's a really great face mill if you use these type of inserts in other machines like a lathe, and then you can use this odd corner of the insert for face mill operations like that. This is one that I don't know if somebody had given me that a long time ago or how I came about it, but we've had it for a long time, ever since we got the Kearney Tracker, and I've only used it a couple of times. So anyway, we're gonna use our 4-inch Walter, and I think that's gonna do a good job. We'll just come right up here and stop. And what I may do, I think what I'd like to do is, after all this is finished, we'll put this back in the shaper. And I think from this section right here, all the way back to that clearance, I think I'd like to use the shaper and just make that linear cut pattern across here that matches this area right there. I think that'll look pretty cool. It'll be something different and unique. I was getting ready to install it, and I noticed brand new tool holder. It's got a couple dings on it right there. I bought this several years ago. I just took it out of the case right there in the plastic, and never used this before. It's an 1.5 inch pilot, and you can feel that ding right there. So I want to go ahead and dress that, and I'll show you. So this is another good reason to have your precision flat stones right here for dressing precision ground surfaces like that. All right, so you just take, I'm rubbing it over that without putting any pressure, and I can feel it's dragging on that high spot right there. So just give it a nice buff there with the stone. You can see it start polishing it up. And all you're doing is just taking the high spot down where it deformed the metal. And that's good. I feel no more resistance there. I think we're ready to start making some cuts. A couple of things to note there. Got it all clamped down. I went ahead and added these toe clamps here just as hopefully a preventative measure in case it does try to push the workpiece back a little bit. So I've got our X set to this point right there. We got our DRO going. We're gonna face it across this way in Y, and then we're gonna feed it that way down the link to cut it. I think that's how I want to make the cuts right there. So as it's rotating, it should be trying to push it this direction against the stops. But we're not taking a big heavy cut, so it should be just fine where it's at. We're running 139 RPM, and I'm gonna run the feed at 9.5 inches a minute. So 9.5 inches a minute, 139 RPM, that's gonna be about 7.5 thousandths chip load per tooth. And I think that was around 145 surface feet a minute is what we're running there. So we're gonna go ahead and fire it off. And we'll get it touched off in Z and start making our first pass. There we go, there's our touch off. Let me set a Z depth. We'll just take this in a couple stages, so we're gonna take 50 thousandths. Okay, let's see if we can make this happen. Bring it back to the middle. All right, let's feed it in X. That looks good. Yeah. All right, well, that went as I expected it to, and everything went good. We didn't have any problems. Like I said, we're not taking heavy cuts here, so that's perfect, working out good. I'll clean this off, and what I'd like to do is go ahead and get a depth measurement. We'll use a depth mic or some calipers, but we'll probably use a depth mic. That way we can get an accurate measurement down to our spacer right here, since we're sitting on that, and see where our height is. All right, we'll get our measurement right here down to this spacer. So our finished dimension from here to there is 4.8 inches. That is reading 4.9, right about 907. Let me go ahead and do that one more time. Yeah, 4.907. So we have 107 thousandths to come off of that. So we'll just take that in 2 passes there. All right, another good cut. Let's go ahead and make a measurement. I'm going to do it with both the calipers and the depth mics. I just would like to see what kind of variation that I get between the two. Hold it down squarely. 849. 848 and a half. 848 and a half. Let's do it again. 848 and a half. All right, let's see what we get with our depth mic. We are getting about 847 and a half. So I don't know, about a thousandths difference there. Let's try it again. Right at 848. So we're within a thousandths, both the depth mic and the calipers there, doing that. So our target is 4.8. So we're going to correct our Z. I'm going to use a dial indicator this time because the digital readout on this machine isn't really all that accurate. And whenever you lock and unlock the table, it actually moves a little bit. So on each side of these Kearney Trackers, you have a lock there on the knee that tightens it up to those ways. And after you make your adjustment and tighten that up, it usually changes 1 or 2 thousandths on the DRO up there. So I'll stick a dial indicator here and either maybe come over to our part or either down there, wherever it's easier to see, and then we'll make that final adjustment Z up for our last cut. Okay, let's make our movement. So I got that dial set to 0. I'm gonna unlock it and see if it moves any. That was unlocked. Oh yeah, see it dropped 2 thousandths. So I'm gonna take it to 48. And we'll relock it and see if we can keep our position. All right, it's 48. All right, that's locked. So what did it do? Yeah, see it changed 2 thousandths right there. And that's just one of the issues that I've always had with the Kearney Tracker. It's a decent mill, but it's not a great mill. It has its problems. It's not 100% accurate anymore, but it's good just for some basic milling. So I'm gonna drop it, remove the backlash. Let's go up to 46. All right, I'm gonna relock it. Let's see if it corrects itself. Okay, that looks good. We landed on 48. That should be right because we started on 0 before we unlocked it. So you can see couple of thousandths difference whenever you're changing the or unlocking and locking the knee. It's all over. It's X, Y, and Z on this machine. It's just got a lot of wear. This machine was used very heavily in its life for whatever it did, but it's still good for our fun shop projects like this. Okay, let's get our measurement here and see if we hit our target. 4.8 is what we're looking for. Let's see how we did. Looks like we're right on 4.8. I think we did pretty good. The friction thimble on this depth mic is way too tight. That's why I just use my fingers there to try to get it. So I'm getting about a 1/2 thousandths difference every time I measure it there. So it looks like we're maybe a 1/2 thousandths off on that. So I'm gonna call that good, or 4.8. I am happy with the finish. I think our Walter face mill did a good job. It's a little bit smoother right here just because, you know, we went across there twice there. And this looks really nice. Now when you get down here to the end, I think you guys can see the marks right there. The reason why it does that is the mill itself. I believe it's just so much wear in this table that you have a couple thousandths variation whenever you go from one side down to the other. So even though we've got a good part here on size, we may be 1 or 2 thousandths off on being parallel and flat just because of how much wear is in the milling machine right here. But it's not going to make or break this job. Maybe we'll do some inspections later on this and kind of see about where we fall on our dimensions. But I did want to point out, that's why you see that right there. It's just as it gets, the table's all the way down here, it starts changing just a little bit and it starts digging in a little bit more, maybe about a thousandths. But it feels really good. If you felt that, it's just nice and smooth across there. And I think that's a perfectly acceptable finish for a part such as this right here for a vise.